next thing I want to talk about is something called dilutions. So this is related to molarity. Now, dilutions are just adding more solvent to make a less concentrated solution. So if you ever see the word dilution, there is one and only one equation you need to think of. So dilutions you want to think of C1 V1 equals C2 V2. And sometimes you'll see this as M1 V1 equals M2 V2. It's the same equation. So the C's or the M's, depending on which one you see, it just represents the concentration, and V is volume, right? So if I say, for instance, what volume of 12, so let's see, volume of 12.1 molar HCl is needed to make 250 milliliters of 3.2, I'll put a decimal there, molar HCl. So again, it's the same because we aren't adding anything new, or I shouldn't say we aren't any new chemicals. We're not adding any more solute. All we're doing is adding solvent to make a solution of a different concentration, right? So in this equation, you'll always, it doesn't actually matter which side you make where you put the numbers, as long as the volume and concentration that are given together are on the same side of the equation. You'll always be given a volume and a concentration together, and then you'll always be given one more, either volume or concentration, and you need to find the missing value. So here, we say we've got 3.2 molar, so that could be our C1, which means that the V1 has to be the volume associated with it, 250 milliliters, and you don't actually have to convert to, for dilution problems, you don't need to convert to liters. You can, but you don't have to. You'll get the same answer either way. And that equals C2 in this case is the other concentration, 12.1, and V2 is what we're looking for, the volume associated with it. So you can just multiply these and then divide both sides here by 12.1. So that cancels out that those right there. That isolates your V2 variable. You can just do that math. You end up V2 equals 66.1 milliliters. And that's it. And every dilution problem is basically just that kind of thing. You might end up having to look for a concentration instead of a volume, but it's always going to be exactly that. So if you ever see dilution, or if you ever see something saying you're just making something less concentrated, just adding solvent, this is always the equation you need. With that, I just want to finish by talking about some other concentration units. So something called molarity. Molarity has a unit of lowercase m, and that is similar to molarity, but a little different. So it's moles of solute over kilograms of solvent. So the denominator is a different part compared to molarity. You have mass percent. So mass percent, and of course the unit for mass percent would just be a percent. So it's the mass of the part. When I say part, just whatever you're looking for. So sort of like in the video where I gave you the percent compositions when we were solving for empirical and molecular formulas. For each individual element, you can think of those as their mass percent of the entire sample. Right? So it's the mass of the part that you're looking for over the mass of the whole times 100. And the 100 is just there to get it into a percent form. There's a volume percent, which is the exact same thing, but instead of mass, you have volume. So volume of the part over volume of the whole times 100. For these two, it doesn't actually matter what your units are. Just as long as the units between the numerator and the denominator are the same, right? So it could be any mass unit just as long as they're the same mass unit. Here, you could have any volume unit just as long as they're the same volume unit. And I say that because next we have mass by volume percent. And sometimes you'll just hear it described as mass by volume, but it means the same thing, even if it doesn't explicitly say the word percent. So this is the mass of the part in grams. So this one has to be mass in grams over the volume of the whole in milliliters times 100. Right? So mass by volume percent, that does have to be in specific units. The mass unit is grams, the volume unit is milliliters. And then just two more. We've got parts per million. Parts per million, which the unit for that is just ppm. And that's going to be very similar to mass percent. You're going to be just doing the mass of the part over the mass of the whole. But this time, instead of multiplying by 100 to get into a percent, you have to multiply it by a million, which is 10 to the 6. And the last one is parts per billion. ppb, which I'm sure you could probably piece together, is the mass of the part over the mass of the whole times 1 billion, which is 10 to the 9.